Hey, Alex again with a quickie. Now I'm not going to do too many of this type of video. I usually tend to gear things a little bit more toward the technical aspects because I found that tends to be lacking. This is going to be more of an overview. I'm going to do these every once in a while just to bring more people into the community and kind of stimulate some thoughts. But if this is your first time watching a 3D printing video, welcome. Now, it's a type of manufacturing that's been around forever, but it was locked up behind design patents. And just in the last few years, some groups of various people have worked on open source projects to try to put that into people's hands. And the entire thing has just exploded with popularity. And that was done through things like the RepRap project and by people like me, just nerds making videos and blog posts for people to follow and kind of kickstart their imagination and get them involved in the whole thing. Now, 3D printing takes thermoplastic, melts it, and deposits it one layer on top of another until you build up a three-dimensional shape. And in this video, I wanted to specifically focus on what owners of guitars and musical instruments and what builders and repair persons of musical instruments can do. Just in case you've ever thought about, maybe I'll throw out a couple $100 and try one of these things out. So I made a list here. Somewhere I made a list. Somewhere. Of just a bunch of things that I thought off the top of my head. It's by no means inclusive, but this is stuff that you can use a 3D printer to either save time, save money, or produce something that you've always wanted but just isn't out there. Basically anything out there that's made out of plastic, and a lot of things that are made out of wood, and some things that are made out of metal, you can print a 3D part for it. So for something like just the hardware that's on a guitar, knobs, pickup covers, pickup rings, electronic covers, jack plates, switch plates, strap buttons, truss rod covers, custom logos, even inlay material, bridge pins like for an acoustic guitar, string retainers, shims, washers, tuning knob ends, and of course a lot of this is going to take knowledge and practice and tuning in your machine and all that kind of stuff. If you're here, you're on YouTube, you're watching this video, you have access to all the other videos from the 3D printing nerds of the world. And many of them are guys that are just like me who are just trying to pump more information into community to stimulate growth and make everybody's lives better. Now, speaking from a luthier or instrument repairer, builder, that type of thing, this is where it gets more into the saving money and that it's very nice to be able to make custom tools for yourself. Now, I build guitars every once in a while just for fun. I get the itch every now and again, more on like a hobbyist enthusiast type of a level, and special tools for luthier type of things. That's something you have to be able to get enough use out of it to make that cost-benefit ratio tilt in your favor. But generally people in this position are doing it for the love of the craft or the love of the end product, and they don't want to spend like 50-60 bucks on it. Now, I'm not trying to take business away from the guys who make these tools. They need to make their cash too. But the guy that's going to use one of these tools once or twice, they're not the guys that were going to buy that $50 fret file anyway. So here's some options for you. Here's a luthier's list. Radius gauges, that's something you can easily print out on a 3D printer. Fret beveling files, sanding radius blocks, non-marring plastic wrenches, routing templates, that's a huge one. Knob pullers, string spreaders, jack screws for repairing internal bracing, drill depth stops so you don't drill through the body when you're not trying to do that, neck support blocks, sanding blocks, neck relief jigs, sanding discs, clamp calls, drill guides at custom angles, that's a nice one, as well as like rigs for your Dremel, rigs for your drill. And if you're wondering how these parts end up, of course, since you're depositing plastic in layers, you're going to have little ring lines. Think of it like grain in wood. But just like grain in wood, you can fill it, sand it, polish it. As an example, here's a knob that I printed out just for this video. I took a couple close-up pictures so you can see that. Here it is, just sitting fresh off the printer. That's what it looks like after it's been pulled off. Here I polished it with some 400 grit sandpaper, and then I polished the knob up on a piece of paper a little bit. I made it a little comically oversized just so it would show up better on camera. But there's some nice details in the knurling. And I managed to polish the top up fairly decently with about 2 minutes worth of effort. I also 3D print various guitar picks for myself. So now you're thinking, well, that's great, but where do I get the things to actually print? There are sites that host just 3D models that you can use. Thingiverse is a very popular one. Umagine is another one. GrabCAD is another one. There's a ton out there. Usually you have to register with your email, and because they like everybody, they do a whole dumb community thing. So you're like, hey, here's my page with my collections of whatever. But it's not a scam. They're just trying to do a thing. Those have collections of these things that other users make and then share around. You can download them and print them out, see how they work. And there's also a lot of free Cad and Cam software out there these days that works pretty well. It's still a little bit steep as far as the learning curve, but I personally think that the best area for people that are just not CAD experts and don't want to spend a whole lot of time learning this, what's called direct solid modeling, which usually you start from primitive shapes like cubes and spheres and rectangles and build them into objects and then carve away at them with various mathematical tools. So let me show you a couple examples. I don't know why I'm pointing over there, of how you would build up these objects, and then I'll give you an idea of how things are going to go. And I will stick this knob on this guitar right back here. For the sake of keeping this short and sweet, I only gave a couple examples. Then I'm going to do the outro part of the video, and then I'm going to cut back in with a few more examples that are slightly more complicated. That's just because I didn't want to make a 20-minute video of me just blabbering while I do something in CAD. So here we go. Here's a custom pendant / guitar pick I made using the logo of a friend's band called Death Therapy. Check them out, they're pretty cool. And that was just built up like this. I used a splined line and then just dragged it across here. It's just one of the tools you could use to do this, but I figured this would be quickest for an example. And make a general guitar shape, or I should say guitar pick shape. And then you just use an extrude command, grab the surface and pull it up as far as you need for whatever thickness of guitar pick you're interested in. Here's an example of how to make a simple knob. We're just going to drag a cylinder onto the plane, drop it down, and then to make a hole, we're just going to take another cylinder, make it whatever the diameter of our shaft is, make the magnet tool to center that down there, sink it into the body of the object like this, and then you just subtract the one from the other. Then there are tools you can use on the edges like bevel and chamfer, and those will just let you make that kind of dome shape on it. And you don't have to stick with just dome knobs. With a little bit of practice, you can make whatever you want, like a chicken head knob. Now, here's just a quick example of how you can do it. We're just going to draw that shape like you did with the guitar pick, stick a dome on top, and then we can go select the plane and extrude it a little bit. Make sure that you're merging that as a solid. And then you have something that generally looks like a chicken head knob right there. We're going to use the press function on the bottom, and then just round the edges off again like we did with the dome knob to make it look a little bit, nicer. So there you go. I hope that piqued your interest. If you have any specific questions on the material covered in this video, drop me a line in the comments underneath. I try to check those at least once a day or so and respond as best I can depending on how much time I have available. So I'll get to them. You can also check out Thomas Sanlanderer's page, Salamander's page. There's also Angus on Maker's Muse, and Joel Telling, the 3D printing nerd, CNC Kitchen, and the list goes on and on. But if you take those basic sites and then look down the sidebar where they have recommendations, you can check all the other 3D Printing Geeks channels and see which ones resonate with you best. So thanks for checking it out. Like and subscribe. If you like my style of doing these videos and you want to see more, I try to get out as much free information as I can to the community, but I have support links underneath if you want to throw me some cash in one form or another to keep this thing going. This channel's just getting off the ground, but the broader audience and more financial support I get, the more elaborate subjects I can cover, so you know how it goes. So thanks again, I'll see you in the next video, and until then, get out there and make something awesome. Or get out there and write something awesome. And then getting onto the luthier tools, we're going to drop a cube in here and then use the press pull function to make it a little bit wider on the edges. And then we're just going to go ahead and round off all of the edges. Then we can go up and drag another rectangle down here. Change the shape to what's going to be the size of our file, and then snap that and rotate it 45 degrees. And then drag this around a little bit so that it's up on our corner. Extend the one edge of that solid through the other solid, and then again just use our subtract function to take it away. Now you have a slot that your file can fit in, and you can add some kind of clamp there to keep it in. Here's a quick and dirty way to do something that I have found to be very useful, and I'm sure you will too, because these things break all the time, and that's make a microphone clip. So you could start with, obviously, if you're going to do this in reality, you're going to want to make all of these shapes the dimensions of the actual microphone. I'm just using this as an example. So we make a cone to represent our microphone, and then our cylinder is going to represent the clip, and then you subtract so that you have that angle that it's going to fit at. And then we could just kind of press and pull our edges till we get what we need, and then go up and add a rectangle, which we will shrink down a little bit. And I'll fast forward through the rest of this, but extend that down through, add the little mic part, hollow out the bottom, and with a little bit of figuring and refinement, we have something that looks like a mic clip. I'm going to fast forward through this whole next example because it took a little bit of time, but we're going to make a humbucker routing template. So you just have our humbucker here, and then we make our plane. Then you subtract everything from your plane, and you have your template. Curved surfaces take a little bit of lateral thinking, but if we wanted to make something like a jack plate, we can draw the curve of the edge of our guitar, the bottom edge of the guitar, parallel another one on here. And this is all just to draw the face of this object. And then we're going to take that, and instead of extruding it, we're going to drop a big block on there, just to show you a different method of doing it, and then use that to split the plane of that solid. So you choose the splitting entity as the sides there, and then you could just subtract the parts you don't need. And then we're going to make the hole for our 1/4-inch jack by just taking a cylinder, using the magnet tool to snap it to the face. It should automatically center it there. And then you move it through the solid, and you can subtract that as usual. But first we're going to make a couple screw holes. So whatever the diameter of your screw is, do the same thing. You can snap that to the face, and then just move them around to the corners wherever it is that you want those to be. And once everything is happily in place, you can go ahead and subtract everything from your solid, and you're left with your jack. Now, just a quickie on refining this shape a little bit. I just took this solid and I dropped it onto the plane. Now I'm going to move it down and move one face so that it's overlapping the other one. And then again, do a subtract, and now we have a nice flat face. And then we use the bevel tool to just go ahead and round off all of our edges to make that little look a little nicer and print a little better. And use our chamfer tool, go ahead and select all of those slots, and you could just take that down a little bit, and now you have countersunk screw holes. You can also use the bevel curve on these the circle cutouts here and just round that off a little bit. Now we can see we can combine tools a little bit, and we're going to make a tuner button or key or whatever, just a little end part that fits on your tuner. First, we can go ahead in the center and hollow that out. This is where it's going to mount onto the tuner itself. So again, do that whole thing where you sink it through, subtract the part. Then we have to make it tapered and rounded. So first thing we can do is go ahead and select all 4 of those outer edges. And we're just going to use our hard chamfer tool for that. And once we have that at generally the angle that we're looking for, we can go ahead and select those inner lines and use the bevel tool on that to round it off. And that looks a little bit more like what we're used to with the traditional tuner. And again, you can go use a much smaller bevel on the other sides to sort of round those off into a more natural shape as well. And just for funsies, you can go down a material and see what it'll look like in bronze or wood or steel or whatever you want to see. It's not going to affect the print, but it's nice to look at. And then one final example, getting to luthier tools here. This is making a radius block or a clamp for a fretboard or something like that. So for this, we're going to use a circle tool and just drop it in the middle of our canvas. And then you can set the radius to whatever it is the radius of your fingerboard is. And then go ahead and grab just a square block, drop that down. And this is going to be our actual body of the tool. So we're going to make that to whatever size it is that you want to work with. So again, we do that with just the push-pull tool like this. And then we can use as a splitting body the edge of the circle here to make a cutout, and then just subtract what we don't need. and go ahead and make it whatever length you want, again using the push tool.